My name is Brian Marriott. I'm a PhD student at the University of Alberta, and I work in the lab of Dr. Jesse Jackson. One of my real passions is actually microscopy, so it's actually part of the tools I use where I'm able to use a mouse, and in a living mouse, I'm able to image and see individual cells in the brain of these mouse while they're on a treadmill or while they're sleeping or while they're behaving naturally. And I just think it's so incredibly cool that we're able to see these individual cells and what they're doing in the brain while the mouse is living and behaving. I do remember the one day where we saw activity of these cells during REM sleep for the first time, and it was indescribable because we saw activity of these cells. They were increasing between waking states, and then when the mouse was in the first stage of sleep, then the activity got a little bit higher. But then when we got to REM sleep, we expected this burst and explosion of activity, but there was silence. So it completely refuted some of the earlier research that was published, and it was incredible seeing this in real time. Some of these discoveries could actually be used for research in the future, and we're using some of the knowledge we've gained from this to realize that maybe these cells are more active during this first stage of sleep, and if we can modulate the activity during this first stage of sleep and not REM sleep like we had previously thought, we're actually able to improve and potentially improve memory. It could be extremely useful for both discovering and potentially improving some diseases that are neurologic in nature. So dementia is one potential role that these cells might be involved in. So if we learn how to improve these cells in dementia, we could be helping to improve patients further down the line. The path is long from these types of mouse studies. It may not seem immediately relevant, but we are always in conversation and conferences and discussions with clinicians. So our research, while yes, it is in mice, it could easily impact these clinicians that we're talking to, that we might discover something and they might make those connections that, hey, wait, that's something that we're actually looking at in the clinic. So this may not seem immediately relevant, but it's all part of the greater story of science, that we're building up everything and it happens one piece at a time. I personally love the connections of the brain because it's different parts that are interacting with each other in such unique and indescribable ways. We really haven't discovered the full extent of the brain, and we've really only scratched the surface of all the connections in the brain. So there's so much more to learn, and I think it's so unique and interesting to look at all these connections, both visually in terms of the images that we can create, but also in terms of what these different parts of the brain are doing.